Okay, you ready for your riddle? Now pause the video as soon as I say it so that you can think about it if you want to. Alright, here we go. What 11-letter word is pronounced incorrectly by more than 99% of Ivy League graduates? What 11-letter word is pronounced incorrectly by more than 99% of Ivy League graduates? And the answer is the word incorrectly. That's it. Wonder if you got that. Welcome. Log exponential graph practice. These are the problems that I posted on Canvas earlier this morning. And I know it's kind of late Sunday night, but you will more than likely be watching this tomorrow if you need help with log and exponential graphing. So I want to attempt to give you guys a little bit more of an intuitive approach to graphing these functions, and I wanted to remind you of the important parts of the log graph. So the first two are logs, and the important parts of the log graph are the key point, which you can see here is at 1, 0, and the vertical asymptote is the line x equals 0. So for all logs with no matter what the base is greater than 0, and also the base can't be equal to 1, and really the only bases that we've really looked at are base 2, 10, and e, and sometimes we'll throw in a base 3, but that's really it. And you learned how to transform graphs way back in chapter 3, 2 or 3, something like that, but I know that that's been hard to remember those rules. So anyway, let's look at more of an intuitive approach. Okay, we know the key point is always at 1, 0. Well, why is it at 1? Well, if you look at the log, when x is 1, in other words, when the argument is equal to 1, the log of 1, no matter what the base is, the log of 1 is going to be 0. So the log just goes away. When the argument is 1, the log term, whatever term has the log in it, goes away. It becomes 0. And then y is whatever's left over. And in this case, log base a of x, if x is 1, the log is 0, because you replace the log expression with 0. Okay? And that's how we get the key point. No matter what the base, even if it's a base e, the log base e, or ln, of 1 is 0, and so the ln goes away. So we always will get an exact value for y when we replace the argument with whatever x is going to make the argument equal to 1. So if you look at this over here, this equation, we notice that the argument is actually x minus 4. So what x will make the argument equal to 1? Well, that's x equals, hold on, I'm looking for my blue pen here while I'm talking to you. There it is. Okay, so the x that makes this argument equal to 1 is x equals 5. Okay, so that means that when x is equal to 5, that entire log expression goes away and becomes 0. So if that's 0, then we get y equals whatever's left over, y equals 2. So we get the point 1, 2, 3, 4, 5, comma, 2, which is right there. So we get 5, 2 are the coordinates of the key point. Alright, let's talk about the vertical asymptote. Vertical asymptote is always whatever x makes the argument equal to 0. Okay, so we can see in this case, if the argument is just x, well then the vertical asymptote is x equals 0, because you can't take the log of 0, and that's actually the dividing point. As soon as the argument gets a little bit bigger than 0, then we have a graph, we have an input, and we can get an output. But the 0, whenever the argument is equal to 0, then we get a vertical asymptote. Okay, so let's take a look over here. We see that the argument again is x minus 4, and so when x is equal to 4, that's it. We can see what x makes our argument equal to 0, and so we get a vertical asymptote of x is equal to 4. So those are two key pieces of information that you want to find on your graph, and that'll at least get you close. Okay, now you know that the graph of this log function has to be to the right of the vertical asymptote, and so you know it's going to either look like this, it's going to come over here like that, or it's going to come down here like this. Okay, so one of the two. And so there are a couple different things we can do here to figure out which direction this graph is going to go in. And we could try to find a y-intercept, and typically that's a little bit of work. You let y equals 0, sorry, x-intercept, you let y equals 0, and then solve this resulting equation for x, and then we'd get x. So we would know that the x-intercept is either in between 4 and 5, or it's some pretty big number, way bigger than 5. So it's going to be way out here, 10, 20, whatever. But an easier way, since the log has a base of 2, it's actually pretty easy to pick a convenient value for x and just kind of see where the y is. So a convenient value for x, we already know that when x equals 5, we have y equals 2. We already got that. And we can't go to the left. So what's our first value for x that we could plug in that would get a convenient value? In other words, we want the argument to be a power of 2. We already got 2 to the 0 power, and we want to get 2 to the first power. So if we plug in x equals 6, we get 6 minus 4 is 2, so that gives us a power of 2. So we just plug in 6, and we get log base 2 of 2. Now what's the log base 2 of 2? Actually, it's y equals 2 plus the log base 2 of 2. And we know that the log base 2 of 2 is 1, so we get 2 plus 1, so we get 3. So we get the point 6, so here's 5, here's 6, so we get 1, 2, 3. And so we know clearly the y value is above this point here when x equals 6, and so we know that, let me do that, let me draw the graph in a different color so it doesn't, so you can see it. So we know it's this graph right here. That's it. Now I realize, so the explanation there is a little bit longer than it actually takes to do this, to draw this graph. But with that understanding, with that level of understanding, you should be okay. If you get, obviously, if you get the asymptote and you get the key point, then the rest is just figuring out which direction the graph is going to go in. You know all log graphs have a vertical asymptote, right? Because the domain is limited, but the way to remember that is log with that big long L there, and remember that's the vertical asymptote. That took 8 minutes to explain that. Okay, so I was hoping to get all 4 of these done in one video, but that's not going to happen. Let's try to get the other log one in there. I know. Okay, so we've got y equals, you can see here, the key point, remember, is whatever makes the argument equal to 1. Okay, so what key point, what's the x value of the key point? Whatever makes the argument equal to 1, x equals 2, and when x equals 2, y equals 5. Okay, so that's a key point, 2, 5. 1, 2, and then 1, 2, 3, 4, 5. So we know for sure it's there. And then vertical asymptote, whatever makes the argument equal to 0. Equal to 0. So we get x equals 3. X equals 3 is right there. Vertical asymptote, 1, 2, 3. I don't know why I'm counting these lines. Just started counting. So anyway, there's our vertical asymptote. We get x equals 3. And then, again, we have 2 choices, or 2 options, I should say. It's either going to approach the vertical asymptote up there, so it's going to come down here like this, somewhere here, and then go up like that, or it's going to be coming down here like that. Okay, so probably the best bet is to figure out what the y-intercept is here. Again, there's no perfect way to do this. It's just find another point on the graph and see if it's higher or lower and where it is, and then you can figure it out. So let's let x equals 0. Okay, we get the ln of 3 plus 5. So we have 5 plus ln of 3, and it's up to you here to decide, is that ln of 3 going to be greater than 1, or sorry, greater than 0 or less than 0? And you should realize that ln of 3 is greater than 0. In fact, it's greater than 1. Okay, you should realize that. ln of 3. E to some power is equal to 3. That power has to be bigger than 1 because e is less than 3. And 3 to the first is 3. And so I'll let you think about that. Okay, but 5 plus a number that's greater than 1 is going to be bigger than 5. Okay, so remember our two options. Option number 1 was the one where there was a y-intercept less than 5, because 1, 2, 3, 4, 5, that's 5 right there. And this y-intercept, this clearly says that when x is 0, we get a y-intercept of something greater than 5, and so therefore the graph is going to look like that. Oops, took a little turn there, sorry. And there you go. I'll get back to the other two in the next video.